This video will help you to find the gradient of a line from 2 points. Okay, so when we're talking about the gradient of a line, we're talking about how the line changes as the value of x changes. So we're looking at when x changes, so x is -6 here, and it changes until we get to -2. We want to see when the value of x changes, how does the value of y change? So this will be this distance here, because we can see that here we're at -6, -2, and here the value has changed to -2 and 4. So what we need to do is use the same technique that we've used before to find the difference between the x value at this point here and the x value here. So to do that, we can do -2 minus -6, which will give us the value of 4. And in the y direction, we have that the difference will be 4 minus -2, which gives us 6. Now, the way that we find the gradient is we use the formula that the gradient equals the rise over the run. So our rise is the change in the y values, so that's 6, and our change in the x values is our run. We need to simplify that, and we get 3 over 2. Now it's important that we realize that you need to leave this as an improper fraction. Don't use a decimal or a mixed numeral. Now in this case, we can see that we have the line and it's going in a different direction. And if we have a look at this line and we look at how x changes, so again we're looking at, well, x changes between 2 and 7. How does the y value change? Well, the y value is 3 here, but at our new point it is -3. So in this case, this is going to be a negative gradient because the y value is actually decreasing as x increases. So to do this, what we need to do is again find the difference between the two. So here it would be 7 minus 2, which gives us 5. The difference in the y direction, which would be 3 minus -3, which gives us 6. And so now we do our rise over run. And that gives us 6 over 5. But because it is decreasing, we need to make sure that it is negative. So it's -6 over 5. So just remember that when the line is decreasing, as it is here, then the gradient will always be negative. So the gradient of a line is the slope or steepness of the line. It is calculated by dividing the vertical rise by the horizontal run. The larger the gradient is, the steeper the slope, and the letter M is often used to indicate the gradient. And you need to become familiar with that. So if we have a look at our diagram again, because we want to do this in general terms, we've got 2 points, x1, y1, and x2, y2. Remember, we want this to be able to work for any values of x and any values of y. And like we said, the things that we needed to do was to find the change in x, which is our run, and the change in y, which is our rise. And we know that the change in x is x2 minus x1, which is shown here. We've done this before when we found the distance between 2 points. And our change in y is y2 minus y1, which is the same here. The gradient formula is the rise over the run. So we can substitute in our rise into here and our run, which goes into here. And so we get y2 minus y1 divided by x2 minus x1. Now m is used to represent the gradient, and so this should be something that you become very familiar with, and I suggest that you memorize this formula so that you're remembering that m is equal to y2 minus y1 over x2 minus x1. It's also important to remember that the positive gradients are lines that go up to the right, so here we can see that positive gradient is going up to the right, and our values of x, as it increases, the y value increases also. For a negative gradient, so when it's going in the opposite direction, as our x value increases, our y value actually decreases. So the first step that we need to do to find the gradient of the line between 2 points is first to put x1 and y1 and x2 and y2 with our a and b. And we've got our formula, so all we need to now do is substitute into that formula so that we get minus 5 minus 3, so it's our y values of the 2 points and our x values of the 2 points also. Simplify and we get negative 9 divided by negative 6, remembering that a negative divided by a negative is a positive, so we get 3 over 2. And just really need to remind you here that you need to simplify every single time. Okay, so now with question 2, find the gradient of the line between the 2 points. And again, here it's important to assign x1 and y1 with a point and x2, y2. And we know our formula for the gradient, so we're going to substitute in. Now note this time that we have only one negative sign, and that's on the bottom, so that's going to make our whole number negative. And we have the value of negative 7 over 8, and that's as simple as you can get it. Okay, here we have another question where we have to prove, and remembering that this is a we do, so it's really important that you get involved with this as well. So the best idea is, when I tell you to, is to pause it, and that way then have a go yourself, and then you'll be able to make sure that you've done it correctly by watching what I've done. So to prove that the shape KLMN is a square, the things that we need to do is we need to first of all show that the sides KL and NM are parallel. Then we need to show that the sides KN and LM are parallel. And we also have to show that all the sides are equal. Now one thing that we haven't learnt yet, which is that if we have two lines that are parallel, we should recognise that both of these lines will have the same gradient. So essentially what we're doing in these first two parts is we need to show that KL, the line KL, and NM both have the same gradient. We need to show that KN and LM both have the same gradient. So have a go at doing those. So pause the video and try using the formula that we have learnt so far. Okay, so we've got M of the line, and I'm just using a subscript here, so MKL, that's just to show that we're finding the gradient for this side, KL. So we're going to substitute those values into the formula. So we get 6 minus 2 and 1 minus 7, which gives us 4 over negative 6, and when we simplify that, it gives us negative 2 over 3. So we're going to do the same thing for N and M, so the gradient of NM, so we get 0 minus minus 4 and minus 3 minus 3, which gives us 4 over negative 6, which is equal to negative 2 over 3. So now that we can see that the sides are parallel because their gradient is the same, the next thing we need to do is just write a quick statement to show that they're equal. So the gradient of KL is equal to the gradient of NM, so KL and NM are parallel. So you're going to follow the exact same method of doing that to do it for the next bit. So pause the video and have a go at that. Okay, so again finding the gradient of M of Kn, so the different side now, and we get 6 minus 0 and 1 minus 3, which gives us 6 over 4, which is 3 over 2. And Lm, so we should be able to know that if this is a square, because the question has already told us that it is a square, then our gradient that we get for this next one should also be 3 over 2. So Lm, substitute the values in for x1, y1, x2, y2. Simplify those. And so we get 6 over 4, which is equal to 3 over 2. Okay, so then the final part that we need to do is we need to show that all the sides are equal. So I want you to go through now and using the distance formula, show that all the sides are equal. So pause the video and go through it. Okay, and this is what you should have got to show that all the sides are equal. Now we've already done this a number of times now, so I'm not going to explain how we did that, but that's the working out that you should have got. We can see that all the values are 7.21, so they're all equal, and that's what's required for a square. So now we need to find out, to do our final statement, our conclusion is that NK equals KL, which equals LM, which equals NM, so that just says that all the sides are equal. So, and we're saying the opposite sides are parallel and sides are equal, therefore KLMN is a square.